Hello students, welcome you all to our new platform Career Chooser. Hello students, here this side Vinay Kumar Maurya and we're going to start our new topic class 9th Physics Chapter 2 Forces and Laws of Motion. Introduction. For many centuries the problem of motion and its causes has puzzled scientists and philosophers. A ball on the ground when given a small hit does not move forever. Such observations suggest the rest is the natural state of object. It remained the belief until Galileo Galilei and Isaac Newton developed an theory different approach to understand the motion. Here these are the following reference images which show the following introduction topic. This is the example figure 9.2 from the NCERT which here A shows a spring expands on the application of the force and the B spherical rubber ball it belongs oblique as we apply force on it. When you push the ball from both sides, the ball becomes thin in the shape, and when we relax in the stage, then the ball comes to its original or same position. Balanced and unbalanced forces. Balanced force, equal in magnitude, opposite in direction, does not cause any change in the state of the motion of the object. Here in the first case, it is the balanced force which is for showing the first example, the first figure. Unbalanced forces, unequal in magnitude, can be in any direction but not opposite, causes changes in the state of motion of the object. In the second case, it is unbalanced force. Here figure second shows the unbalanced force. Galileo Galilei's experiment. By observing the motion of object on an inclined plane, Galileo deduced that objects move with a constant speed when no force acts on them. Galileo argued that when the marble is released from the left, it would roll down on the reaches the same height from which it was released in the other side. Here is the case unbalanced force on the marble is 0. So it can be done only experimentally. So here in the real life incidents it is not possible. Here Newton took the advantage of the Galileo's Galilei theory and further studied Galileo's ideas on the force and motions and presented three fundamental laws which govern the motion of objects. These laws are known as Newton's laws of motion. First law of motion. It states that an object remains in the state of rest or state of motion with uniform speed in a straight line unless compelled to change that state by applied force. In other words, we can also say that all objects resist change in the state of motion in a qualitative way. The tendency of undisturbed object to stay at the rest or to keep moving with the same velocity is called inertia. This is the first law of motion, also known as law of inertia. There is the following reference image which shows when the card is flicked with the finger, the coin placed over the card turns or moves or fall inside the tumbler. Inertia and its type. There are three types of inertia. The inertia of rest. Body tends to remain in the rest until an external force is applied. Example, people traveling in the bus tends to fall back when the bus starts as the inertia is moved by external force. The inertia of motion. Body continues to remain in motion unless force acts on it to stop the motion. Example, people tend to fall forward when the brake is applied in the moving bus. The inertia of direction. When a body is in motion, it is a tendency to change its direction and to continue to move in that same direction unless the force acts on it. For example, people sitting at the corners of the bus experience outward pull when the bus moves around the curved road or the sharp point. Second law of motion. The second law of motion states that the rate of change of momentum of an object is proportional to the applied unbalanced force in the direction of the force. It is represented by the formula P is equal to mass into velocity, or momentum is equal to mass into velocity. Here P is represented as momentum, M is for mass and V is for velocity of the object. Here the following reference image which shows a fielder pulls his hands gradually back with the moving ball until to exert less force or pressure on his hand. Mathematical way for representing the formula. Suppose an object of mass m is moving along a straight line with an initial velocity u. It is uniformly accelerated to velocity v in the time t. By the application of a constant force F, throughout the time t, the initial and final momentum of object will be p1 is equal to mu and p2 is equal to mv respectively. So change in momentum is directly proportional to p2 minus p1, is directly proportional to mv minus mu, is directly proportional to m into v minus u. So the rate of change of momentum is equal to proportionality sign of m into v minus u upon t, or the applied force F is directly proportional to m v minus u upon t, or F is equal to k m v minus u upon t, or we can also write it as k into m into a. Here k is the constant to remove the proportionality sign. Here a is equal to v minus u upon t is the acceleration, which is the rate of change of velocity. The quantity k is the constant of proportionality, as I told earlier. The SI unit of mass and acceleration are kg and meter per second square respectively. The unit of force is so chosen that the value of constant k becomes 1. For this, 1 unit of force is defined as the amount of produced an acceleration of 1 meter per second square in an object of 1 kg mass. This is 1 unit of force is equal to k into 1 kg into 1 meter per second square. Thus, the value of k becomes 1. From equation 9.3, that is F is equal to ma 9.4. The unit of force is gram kg meter per second square, or the Newton. Representation of first law of motion with the help of second law of motion. The first law of motion can be mathematically stated from the mathematical equation for the second law of motion equation, that is F is equal to ma, or F is equal to m in bracket v minus u upon t, or ft is equal to mv minus mu. That is, when f is equal to 0, v is equal to u for whatever time t is taken. This means that object will continue moving with the uniform velocity u throughout the time t, and if u is 0, then v will be also 0, that is, the object will remain at the rest. Third law of motion. Newton's third law of motion states that when one body exerts a force on the other body, the first body experiences a force which is equal in magnitude in the opposite direction of the force which is exerted. The mathematical representation of the Newton's third law of motion is, let A be the body exerting force F on the body B, then body B to exert a force minus F on body A, which is given as force exerted on A by B is equal to minus force exerted on A by B. Is the following reference image which shows a forward force on the bullet and recoil of the gun. Acceleration force on the bullet is equal to recoil force on the gun. This is the following reference image to show how third law of motion takes place. These are some other examples. Action and reaction forces are equal and opposite. As the sailor jumps in the forward direction, the boat moves backward direction. Conservation of momentum. Laws of conservation of momentum states that for two or more bodies in an isolated system acting upon each other, their total momentum remains constant unless an external force is applied. Therefore, momentum can neither be created nor destroyed. Here is the following reference image which shows conservation of momentum in collision of two bodies, that is having the mass ma and mb with the moving velocity of ua and ub. Derivation of conservation of momentum. Just to pause the video and read it. We will give this derivation in the next lecture by the handpick method. Thank you very much for attending the lecture.